In this videotape, we're going to do some more work on verbal problems. Let's start by considering four apparently unrelated problems. And as we study them, certain similarities are going to occur. Now, first problem up here. A collection of 30 coins consisting of 10 dimes and nickels is worth $2.60. How many of each kind are there? Okay, you have 30 coins. They could be in your pocket. Okay, they're only dimes and nickels. And you have a total of $2.60, and I'm asking you to figure out how many are dimes and how many are nickels. Let's look at the next problem. 30 tickets to a show were sold and $260 was collected. If the adult tickets cost $10 each and children's tickets cost $5 each, how many of each type were sold? You shouldn't be copying these problems. They should be on a sheet. If you don't have the sheet, you can get one from the attendant in the lab. Okay, so shut the machine off and get one of those sheets. Okay, now aside from the fact that obviously we have the same number 30 coming in and 260 appears in both problems, other similarities, when we actually try to solve these problems, other similarities will present themselves. Let's move on over here. A small firm manufactures pants and shirts. A total of 30 garments can be manufactured in an hour. That's a combination of the pants and shirts. If the firm makes a $10 profit on each pair of pants and a $5 profit on each shirt, how many of each type were sold to make a profit of $260 in 1 hour? And the last problem, Jane and Sue work a total of 30 minutes. By that I mean if Jane works 10 minutes, then Sue works 20 minutes. Together, their times add up to 30 minutes. If Jane can process 10 forms per minute and Sue can process 5 forms per minute, how long did each one work if they processed a total of 260 forms? Okay, let's go back to the first problem, the coin problem. Okay, and we'll discuss solving this. And later on, we'll see certain similarities with the other problems. Collection of 30 coins consisting of dimes and nickels. We want to figure out how many of each kind are there. So let's say let X represent the number of dimes in the collection. And let 30 minus X represent the number of nickels. X is the number of dimes and 30 minus X the number of nickels. Now, I only wanted to use one unknown, one variable in these problems. Okay, I'm letting X represent the number of dimes. Since they're a collection of 30 coins, together you have 30 dimes and nickels. If X of them are dimes, then 30 minus X of them, the rest of them, are nickels. For example, if you have 5 dimes and you have 25 nickels, you take the 5 away from the 30. The same thing, if you have X dimes, you have 30 minus X nickels. Okay, now we're interested in figuring out how many of each kind are there if we have a total of $2.60 in our pocket. Now, what we're going to do is figure out the value of the dimes and the value of the nickels. Now, we have dollars and cents here, $2.60. A dime is 10 cents. A nickel is 5 cents. I would prefer to work always in the same unit. So let's put everything into pennies. Now, instead of $2.60, we have 260 cents or 260 pennies. Okay, and a dime we'll consider to be worth 10 pennies, and a nickel 5 pennies. So you might say that the value of 1 dime is 10 pennies. And the value of 2 dimes, that's 20 pennies. The value of 3 dimes, 30 cents, 30 pennies. In each case, what are we doing? We are taking the number of dimes that we have times the number of pennies in a dime, number of cents in a dime. So we're taking 2 dimes times 10 cents in 1 dime to get the 20 pennies. 3 dimes times 10 cents in 1 dime to get the 30 pennies. Okay, if you have 4 dimes, it's the 4 dimes times the 10 cents in each dime to get 40 pennies. 4 dimes, 10 cents in each dime, 40 pennies. Okay, now in this problem over here we have x dimes. We said x represents the number of dimes. The value of x dimes would be x dimes times 10 pennies in a dime, or x times 10, or 10x pennies. So the value of the dimes, you have x dimes in this collection. The value of x dimes is 10x. 1 dime is worth 10 times 1 pennies. 2 dimes, 10 times 2 pennies. 3 dimes, 10 times 3 pennies. 4 dimes, 10 times 4 pennies. X dimes, 10 times x pennies. Okay, in a similar way, we could figure out the value of the nickels in the collection. 1 nickel would be worth 5 pennies. Let's do a few nickels. One nickel, 5 pennies. 2 nickels, 10 pennies. 3 nickels, 3 nickels times 5 pennies in each nickel to get 15 pennies. And what we've done in each case is take the number of nickels times 5 pennies in each nickel to get the total number of penny, or the value, okay, of your nickels in pennies. In this particular problem, we have 30 minus x nickels. Whereas we had x dimes and 30 minus x nickels. So we want the value of the 30 minus x nickels. Okay, 3 nickels, 3 times 5. 2 nickels, 2 times 5. 30 minus x nickels, 30 minus x times 5, or 5 times 30 minus x, which looks a little nicer. 5 times 30 minus x pennies. It doesn't really matter. You could write x times 10, but we tend to write 10x. 30 minus x times 5, or 5 times 30 minus x. In each case, take the number of nickels times 5 pennies per nickel to get the total number of pennies in the value of the nickels. Okay, now we're going to set up an equation here. We have a collection of 30 coins consisting of the dimes and nickels, and they're worth $2.60, or 260 pennies. We're going to set up an equation in this form. We're going to say the value of the dimes in the collection plus the value of the nickels in the collection is equal to the total value of the collection. The value of the dimes in the collection plus the value of the nickels in the collection is equal to the total value of the collection. If you think of this collection as being the coins in your pocket, okay, it's what the dimes are worth in pennies plus what the nickels are worth in pennies together should give you the total value in pennies of the coins you have in your pocket, which we already said is $2.60, or 260 pennies. Now, you have x dimes, and we already know the value of x dimes. The value of x dimes in penny, that's 10x pennies. The value of x dimes in pennies, 10x. Okay, you might want to make a little note. This is the value in pennies in all of them. The value of the x dimes in pennies is 10x pennies. The value of the nickels in pennies, you have 30 minus x nickels, and that gives you 5 times 30 minus x pennies equals 260 pennies. The value of the dimes in pennies, x dimes at 10 pennies per dime, 10x pennies. The value of nickels in pennies, 30 minus x nickels, at 5 pennies per nickel, 5 times 30 minus x pennies. Total value of the collection, $2.60, comes out to be 260 pennies. Okay. We'll solve this equation in a moment. I want to go on and set up the other 3 equations for the other 3 verbal problems. By the way, it was just arbitrary when I said let x be the number of dimes. I could have said let x be the number of nickels, and then 30 minus x would be the number of dimes. But then you have to be consistent throughout. Okay? Then x would have been the nickels. You would have had 5x here, and here you would have had the 30 minus x times the 10. And at the end, when I get x here, I'd have dimes. The other way, I'd have x, and that would be the number of nickels. But everything would work out the same. It doesn't matter which way you start. X can be either the dimes or the nickels, but you have to be consistent throughout. Okay, 30 tickets to a show were sold. 30 tickets to a show were sold, and $260 was collected. If adult tickets cost $10 each and children's tickets cost $5 each, we want to know how many of each type were sold. I'm going to let x, in this case, be the number of adult tickets sold. And I'm going to let 30 minus x equal the number of children tickets sold. And there's a certain value of the tickets. It's very similar to the coin problem, which is why we're studying these problems together. All of these problems could be sort of considered as value problems. Coin problems, ticket problems, and these other ones that we're going to consider later on. Okay, you can do the same kind of setup. You can say the value of the children's tickets in dollars. Let's make it the value of the adults' tickets first. The value of the adult tickets in dollars. Okay, here we'll work in dollars instead of pennies, because everything is in the same unit. See, here you had a dime worth 10 pennies, a nickel worth 5 pennies, and you had $2. Okay? But here everything is in dollars, so we can stick with that unit. The value of the adult tickets in dollars plus the value of the children tickets in dollars equals the total value of all the tickets. Now, if you send somebody to buy tickets for you, the adult tickets, and one ticket, you got to give them $10. 2 tickets, you got to give them $20. If you wanted 3 tickets and they're $10 each, you have to give them $30. So to get the value of the adult tickets, it would be the number of adult tickets times the cost for each adult ticket. It's very similar to when we found the value of the dimes in the collection before. It was the number of dimes, x, times the number of pennies in each dime. Now x is the number of adult tickets, and the value or the cost of the x adult tickets would be $10 per adult ticket times the number of adult tickets, 10x dollars. The value of the adult tickets, if you send them to get 2 adult tickets, it's $20. 3 adult tickets, $30, because they're $10 each. 5 adult tickets, $50. X adult tickets, 10 times x dollars. In each case, you multiply the number of tickets times $10. So x tickets times $10. Then the value of the children's tickets. 1 child's ticket, $5. 2 children's tickets, $10. 3 children's tickets, $15. You take the number of tickets times $5 for each ticket. Well, we have here 30 minus x children's tickets. 30 minus x children's tickets times $5 for each child's ticket here. And the total value of all the tickets, $260. They tell you the 30 tickets together, okay, were sold and $260 was collected. This is also in dollars. This is $260. The value of the adult tickets plus the value of the children's tickets equals the total value of all the tickets. You take the number of adult tickets times $10 for each one, the number of children's tickets times $5 for each one equals $260 that was taken in at the box office. And of course, you notice that the equation that we get in this problem is the exact same equation that we got in this one. In a few moments, we're going to solve this equation. I first want to set up the other two problems. Let's move on to problem number 3. A small firm manufactures pants and shirts. A total of 30 garments can be manufactured in an hour. If the firm makes a $10 profit on each pair of pants and a $5 profit on each shirt, how many of each type were sold to make a profit of $260 in 1 hour? Okay, we want to know how many of each type were made. Let X be the number of pants made in the hour. The number of pairs of pants. Manufactured in the hour. Since we're making a total of 30 garments, okay, 30 garments together, if X of them are pants, if you make 5 pairs of pants, then you must make 25 shirts. Okay, because together, the number of pants plus the number of shirts made, that's 30. X pairs of pants, so 30 minus X. That's the number of shirts manufactured in the hour. Okay. Now, we're looking at the profit. You could think of the profit of making a shirt, okay, as the value of making the shirt to the company. So once again, it becomes a value problem. Okay, the value of the pants made plus the value of the shirts made is equal to the total value. In this case, I'm talking about value as a kind of profit. The profits from the pants plus the profits from the shirts together, the total profit taken in. Now, you were told the total profit taken in by the company at the end of 1 hour, $260. Okay, everything here is going to be in dollars. In dollars. Value of the pants. Now, from 1 pair of pants, you make $10 profit. 2 pairs of pants, you make $20 profit. 3 pairs of pants, $30 profit. It's the number of pairs of pants that you make times $10 profit on each pair. So if you're making X pairs of pants, X pairs of pants at $10 profit per pair of pants, 10X is your profit or the value of the pants. Now, you're making the rest shirts. If you have X pants, you have 30 minus X shirts. Now, 1 shirt, you make $5 profit. 2 shirts, you make $10 profit. 3 shirts, you make $15 profit. It's the number of shirts made times $5 profit per shirt. So we're making 30 minus X shirts. 30 minus X shirts times $5 profit per shirt to get the value or the profit from the shirts. And you will notice that this is the same equation, 10X plus 5 times 30 minus X in parentheses is equal to 260 that we got for the other 2 problems. Okay, let's look now at the last one. Okay, Jane and Sue work a total of 30 minutes. Okay, if one works 10 minutes, the other one works 20 minutes. Together, they're working the 30 minutes. If Jane can process 10 forms per minute and Sue can process 5 forms per minute, how long did each one work if they processed a total of 260 forms? Okay, let X equal the number of minutes worked by Jane. And then 30 minus X Let's get that I work 30 minutes. 30 minus x is the number of minutes worked by Sue. Okay, now you can think of this, the equation we're going to set up as the value of Jane's work plus the value of Sue's work, meaning the number of forms they process, is equal to the total value of their work, which is the total number of forms processed. Okay, value of Jane's work, okay, that's in forms processed, plus the value of Sue's work, also in forms processed, equals total value of their work, total number of forms. The total number of forms processed, 260. Jane, if she works 1 minute, does 10 forms, 2 minutes, 20 forms. She's working X minutes, so she's doing 10X forms. Sue's work. If she works 1 minute, she does 5 forms. 2 minutes, she does 10 forms. 3 minutes, 15 forms. Each case multiplying the number of minutes times 5 forms per minute. She's working here 30 minus X minutes, and she does 5 forms per minute. So the value of Sue's work, the number of forms she processed, is 5 times 30 minus X. Added to the value of Jane's work, you get 260, the total number of forms. Okay, you will notice that all 4 equations, let's go back and look. In each case, the verbal problem, although they're entirely different word problems, in each case, the verbal problem gave rise to exactly the same equation. Let me write that equation here in the middle board. It was 10x plus 5 times 30 minus x equals 260. We're going to solve this equation and then go back and look at the 4 problems and interpret our answers. Okay. Now, 10x, now distribute the 5 through the parentheses. 5 times 30, that's 150, minus 5 times x equals 260. 5x plus 10x minus 5x, that's 5x, plus 150 equals 260. Subtract 150 from both sides. 5x equals 110. Divide both sides by 5. X equals 5 into 110 goes 22 times, goes evenly. X is 22, and the other unknown in all the problems was 30 minus x. Okay, 30 minus x, 30 minus 22 is 8. Okay, so in all of them, all of the problems, you had the same equation. We've solved the equation. We get x is 22, 30 minus x, that's 8. Let's go back and put our answers in. I'm going to erase this. I just want to have room here to interpret the answers. Okay, in the first problem here, x is the number of dimes. So you have 22 dimes and 30 minus x, that's the number of nickels, 8 nickels. Let's check the answer. We have a collection of 30 coins, 22 dimes and 8 nickels. Let's figure out the value. Don't go back to the equation you have here. Go back to the words of the problems. Ask yourself, well, say 22 dimes. Okay, this must be worth $2.20. 8 nickels, 8 times 5 cents each, 40 cents. For a total of $2.60. So it checks out. 30 coins, 22 dimes and 8 nickels, giving us $2.60. That's the value of the collection. And that's correct. Okay, back over here. Problem number 2. Once again, x is 22 and 30 minus x is 8. Okay. X is 22. That's the number of adult tickets. So 22 adult tickets. And 30 minus X, 30 minus 22, 8 children's tickets. Now, that's a total of 30 tickets. 22 adults tickets at $10 each. That gives you $220 taken in at the box office. And then you have 8 children's tickets at $5 each for a total of $40. And that gives you $260. And it checks out. 30 tickets, $260. OK, let's just look at the last two problems here. Okay, and if you go through your answers, here we're not going to go through all the check. X is 22. You have 22 pairs of pants, 8 shirts, and you're getting a profit, $10 each. The numbers are exactly the same as with the tickets. 22 pairs of pants, $10 each for $220, and 8 pairs of pants at $5 each for profit, $40, a total of $260 in this one. And finally, Jane here, X is going to work 22 minutes, and Sue works 30 minus 22, 8 minutes. She processes 10 forms per minute, so she gets 220 forms done. And at 8 minutes, 5 forms per minute, she gets 40 forms done, total of 260 forms. Okay, so different problems, same equations, and we get the same answers, but we interpret them differently in each of the problems. And that brings us to the end of this tape.